What is up, my dudes and dudettes, and welcome back to Scrap Mechanic. Today, once again, in the survival world, where we're trying to modify this old Learjet into a proper survival plane. Now we're gonna pick up where we left off last time, and that is we got it out this airplane, and now it's pretty light and ready to receive all the systems that are necessary to make it fly. So today I have planned to build the very basic systems that are needed to make this plane fly. Just a very simple control system, thrust system, and not much else. Just to have, a basis for all that is to come, so we can do proper flight testing in between the build sessions. So first, let me add some wings here in the middle. And when I'm building this, I'm going to tell you why we do it. And add one controller for the flap system. I think the flap system won't be a flap system in the sense that you can lower and raise the flaps, but those will have a fixed settings, I think about 15 degrees. Because we're not going to have a big range of speed we're going to fly in. Once again, we're limited to about 100 blocks per second. So basically we're going to take this airplane off the ground, out of the water, and it's pretty much already at cruising speed. So we're going to have this flap setting of, let's say, 10 to 20 degrees, something like that, to provide additional lift. And that's going to be enough for us. So first we're going to build the wings and the flap system. Let's go. Okay, so that's not looking too bad for now. What I did was I installed the controller, set it to 15 degrees for the flaps, and I also added some additional wings here hidden in the fuselage, because these wings are quite short, stubby. They are not a lot of wing pieces, so we'll have to compromise and add some more. And what we saw last time, the plane was quite nose heavy, but sat in the water quite tail heavy. The reason for this is the nose heaviness came from the aerodynamic effects of mainly the flaps, I think, because these were turned down, and they are behind the center of gravity, and that means it's pushing the nose down, it's pushing the tail up, the center of gravity, around the center of gravity, which is around here, I guess, pushing the nose down. So in front of the center of gravity, we need another force, another upwards force, and that's why I put these rows of 15 degrees upwards airfoils there. So hopefully we can counteract the force produced by the flaps, and we're gonna find that out once we do the flight testing. But first, let me load in another mod that I forgot. See you in a second. Alrighty then, before we continue, let's just check the center of gravity. I've loaded in the Engineers Toolbox mod. And we will have a block here, which is called the Center of Mass Finder. So we're gonna take that, we just glue it on anywhere on the creation and activate it. And now we have the center of mass for this creation. And yeah, this should move forward quite a bit. Which is no problem, because I think we're going to build all the systems like right here in the very front of the aircraft, so we don't need any heavy blocks to restore the balance to this aircraft, but just continue building. So we can let's delete that for now. We can check it on later, and let's start building the systems. Okay, for that we're gonna need let's call them the smart parts from the mod pack. A tick button, a counter. Let's take a number block. Let's take a math block. Let's take a memory panel, and that should be enough now. Oh, and also we need, of course, smart engine controller. So we're gonna have one Well, let's put it right in the front already. So we're gonna have one smart engine for, let's put this right here and right here, and that is one smart engine for the aileron and one smart engine, of course, for the elevator. That's not beautiful. That's better. Okay, this is gonna be a multiply block. So now we're gonna have two memory panels that are gonna be for the speed and the power of those control surfaces. So let's program these. So speed, let's just for now 100. Let's just say 100 degrees per second. It's not too fast, not too slow. Remove this memory panel, reset the counter, the power. We're gonna have just very high power, 10,000 units. I don't really know what the power does or how much is much and how much is little. But 10,000, 100,000 is normally enough to make the control surfaces that powerful that they are not, afflicted by any collisions or stuff. They're just very stable that way. Right. That is for both the engines. So the right engine is gonna be our. Oh no, let's stop this. We're also gonna need this input. The orange input. The orange input here is gonna be the degrees, the target degrees. If we do not have an input, the bearing will just rotate at 100 degrees per second with a force of 10,000. So therefore, we have to give it also an input of the target degrees, which is 0 at the moment. This seems a bit slow, 100 degrees per second. Yeah, let's go. Let's go 200 degrees per second. Reset. 200 degrees per second. Cool. So we need to hook this up to these converters. So this is the elevator. These are the ailerons. So this converter will now output a value between -1 and 1. So left and right. Right now it's 0, 1, and -1. And of course we don't want to have 1 degree up and down, but we want to have, let's say 30 for now. So once again, we're gonna need memory blocks or memory panels. And we're gonna do different values for the elevator and for the ailerons. Maybe it's the same value in the end, but for testing for now, let's have a different value. Reset this. Give it a value of 1 to 30. Save it. And for now, let's have the same value here, 30 degrees. Now, 1, 2, 3. Nice. So this should already work with the ailerons. Right, that's looking good. It's just in the wrong direction, but there's no problem. Change this, and we change this. And that's the ailerons done. Let's do the same with the elevators. Perfect. Yeah, something needs to change here. Yeah, the thing is, we'll also need the trim on this control surface. So we have to have an additional value that is added. It is added to this control input value before we actually have this. So now we have a math block addition block. So we'll take this, which is 0 at the moment, and then we can insert our trim value plus minus x degrees right there. But for now, we're gonna just leave that open. You can already, let's put the counter there. That's gonna be the counter that does the trim. Cool. So finally now let's do the thrust control system, and then I guess we can already go for our first test flight. So we're going to do now what's called a limited counter. I want the counter to have a range from 0 to 100, and we're going to multiply this value, the output value, with another value to give us the thrust we need. So this is, we could say this is a percentage counter, 0% to 100% thrust, and 100% thrust times the multiplication value, just let's say 10. So we have the range from 0 to 1,000 in the end. So that's, you can already put this multiplication block here and a static value here. And this is going to go into the engines, not directly into the engines, but into this block, which should be, no, that's bull. Okay, I'm starting. We're gonna have an addition block in the engines, and then we can connect that up. The reason is we also need to make sure we can have asymmetric thrust. So one side provides more thrust than the other for turning, for the rudder function. So that's why we have this additional math block in between. So this goes to the engines. And then we can also insert plus 100, 200. We can add a force here and subtract a force there, or vice versa, to have asymmetric thrust. Good, but that's looking fine. Now let's make this counter limited. I think we have to paint it white already. So, want to have the range of 0 to 100. So, can have 2 multiplier blocks. Then we have 2 checks. We have the greater and less than function. And then we need 2 static values. These are going to be colored black because the counter is going to be compared to these static values. So for one of the values we need to be 100, and the other value needs to be 0. Okay, so this block now has the value of 100. Why do we need it? The counter needs to be greater than 0 in order for this to work. So this is the 0, and the right side should be the 100 value. Right. So let's connect this to the checks, and let's connect the counter to the checks. So what this now does, this is the decrease side, and this is the increase side. So as long as the counter is less than 100, we can increase the value. As long as the counter is, let's set this to equal. No, that's not. Yes, as long as the counter is greater than 0, which is not the case at the moment because it is exactly 0, we can increase the value. No, we can decrease the value. That's also why we have to paint this gate with a dark brown color. This will mean that if this is activated, it will provide a value of -1, of -1. This will provide a +1. Cool. We also need 2 buttons. Let's put them here. It's a plus and minus button. Good. These need to be connected to here, and that should already work then. Okay, that's not looking too bad. Let's check the values. Okay, this limitation does not seem to work. We have to work on that. That also does. Why? I did connect this up, right? Okay, yeah, well, of course we have to connect the checks up for it to work. Now we cannot decrease the value, we can increase the value up to 100. Because of the ticks left in the system, it will overshoot, but 100, 102 doesn't make a difference. So in the other way, we don't want to have -2. So we're going to insert a little safety system with a logic gate. So let's put that here for now. We're going to have a logic gate, that is a NOR gate, and that will check if this condition is active, if the counter is higher than 0. Yeah, we need to go greater equal than. So, and this has to be white now, which means if the counter goes into the negatives, this will light up and will reset the counter. So now we can increase the value up to 100, and we can decrease the value down to -2, but as soon as we go below 0, this will reset. And now we have a limited counter from 0 to 100. So now all we have to do basically is find out how much power we need, how much thrust we need. What is this static value? And yeah, we have to experiment for that. For now, let's take 1, 2, 3, 4, 5, 50. So this now should theoretically work. Button 3, button 4. So let's see now. Well, okay then. Well, I will guess that 50 is a bit too much. So, I see you in a minute. I'm gonna catch the plane and continue from there on. Hey there, little buddy. Why are you going backwards? Right, it's also probably a good idea to, as an additional safety measure, put this in. That checks if a seat is occupied by player. See, now it lights up and emits a signal. As soon as I let go, it doesn't. Okay, and this signal will go into this multiplier block. So no matter the value of this counter, if this seat is not occupied, the engines shouldn't be working. So let's check that out. Perfect. Very nice, very nice. Let's reset this. And let's lower this value. We had, what did we have now? 50, I think. Okay, let's try it. Are we connected? We are. Let's try it with 10 for now. That is also way too fast. How about 5? It's too fast. We're going too fast. Definitely going too fast. Don't leave me. Really good idea to couple this seat with the thrust, actually. But that didn't look too bad for now, I would say. 5, still 5 is too much. 5 is still too much, so let's go with... How about 2? How about 2? Go full power. That does not look like it's enough. Let's see here. What about 3? Yeah, picking up speed. It's not looking too bad. Come on, there's a lot of resistance in the water, so if we manage to get out of the water, then everything should be fine. But this is still not enough. So let's go with 4. What I guess what has to happen with this plane also is we have more thrust than we need in the end just to get this plane out of the water where there's a lot of resistance, and then aerodynamically limit the speed this airplane has. So we're going to apply speed brakes automatically when the airspeed crosses a certain value. So, but let's just find out the minimum thrust necessary to get this plane out of the water in this stage. So basically this should be now 400 power per engine, and this will lift us out of the water very nicely. But yeah, we are accelerating. Come on down, boy. I think we need more flaps, steeper flaps. that will limit our speed, our top speed. Let's try that now. Let's go to 30 degrees. Okay, that of course changed our trim. So I guess I will, but the speed's looking not too bad. Yeah, I should replace those wing parts inside that are 15 degrees now with the 30 degrees parts. Oh, great. I'm over water. That's just great. I fell through the water, which is even greater. Let me get my jet. Okay. So we need some wings, and we're gonna take the 30-degree airfoil, and maybe it's enough if we just replace the top ones here. And let's flight test. Full power there. Get it out of the water. That's already looking much better. I mean, we still need some more real trim, but that shouldn't be a problem. If we trim this plane up a bit, no, trim by hand, I mean, this should work very nicely. Looks like we are already quite fast for this configuration. So that's promising. I don't want a fast plane, I want a slow plane. So let's see if we can fly a little slower here. Like, imagine that this plane is trimmed out. That would be very nice. That would be okay to fly. Oh, there's the trader, nice. That's looking so cool from above. Alrighty, let's find a spot near the water and land, because this is gonna be it for today, folks. Awesome. Okay, I'm very happy with today's progress. So we're gonna end this one here. Guys, if you like the video, like it, give it a thumbs up, subscribe to the channel, it really helps me. And yeah, just do all the interaction stuff, comment. Also check out my workshop on my Steam profile. It's also named Left Playing. I can also link it in the description. There's some other cool planes you can check out. Yeah, but for now that's it. Next time we're gonna improve the flight dynamics of this plane and add some more systems. So until then, have a great week and bye bye.